Good day again, and it's new video lesson also about time domain electromagnetic, but it's will dedicate to very simple workflow. An idea to make this video lesson was initiated by some posts in LinkedIn. I read about some profile data and how to handle it to get some normal layered structure. We discussed LCI inversion for doing it, and now I would like to demonstrate this very simple workflow. Here I have some time domain electromagnetic data. It's in loop array with several with many transmitter loops and with receivers inside loops, different parts of takes loop. So this is quite complicated situation sometime, and here is a very different level of noise and some measurement made inside, some of them outside loop. You can see positive and negative crossing zero curves, so it's sometimes very challenging to invert such data. And I will demonstrate this workflow. It's about 3 kilometers line, and here is, I don't know, maybe 60 soundings along this line. And as I said, it has very different signal to noise ratio. So if invert this data separately, it can be very different models, and it couldn't be combined in one normal 2D image. So we need some tools for it. Recently we developed this pseudo 2D inversion, and this pseudo 2D inversion, nothing 2D, just smoothing operator. So it has a 1D core, 1D forward problem, 1D Jacobian, but it's I use this 2D smoothing operator, and it gives us pretty good results in case of our section is layered. Here you can see starting model. It's 200 ohm meters, and you couldn't see theoretical apparent resistivity. It's a straight line practically everywhere. That's mean nothing wrong with it. We just use here true apparent resistivity, not later time formula. That's why it's maybe looks different from you used to seeing in time domain electromagnetic. So, but it doesn't care because we use signal in inversion. So I would like to use this pseudo 2D inversion, and for pseudo 2D I can typically make my smoothing factor lesser, and all I need is just to set number of layers. Let's see how many layers here. And also I need during inversion, I would like to control misfits for every station. So for that, I will turn on these options. Plot RMS color bar. It will show me misfits in red, green, yellow colors for all stations. And number of iteration 9, I think it's okay. So we just can do this inversion. Of course, it's take 16 times more time. It's longer than separate in the one station inversion because all stations is involved in this inversion. So it's much more time consuming, but we it's cost. So let's wait a little till first iteration will be done. So what this pseudo 2D inversion do? It's calculate Jacobians for current model for every station and calculate signals for every station. It's combines it to one system and it's connected all these stations between by smoothing operator. As you can see, first iteration give us very pure model with no contrast anomalies. So we should wait. Because already with second or third, we will see improvement. Now I can see it's already different, and this because it's true apparent resistivity here. It's our section may be pretty similar to this pseudo section. I think after our third or fourth iteration, we will see significant change in colors of this error color bar, because now you can see it's a misfit between measured and predicated data already about 20%. But you can see that data quality here is terrible. So, but it's not mine data, and I am not responsible for it. Anyway, you can see it's already changed, and there is some progress. We still can see this anomaly. I can see it here. I think this is just some station problem, yeah, because it's not confirming on the neighbor stations. But we have very dense station position on this line. So let's wait till inversion finished. Okay. I think we are in the middle of this way. So let's wait till these small bars became more greener. Some of them, because in case of first station, it's can't happen because it's very noisy data and we have no error gates for this data set. I think this point is some spike in data, and it's for pseudo 2D, it will be not any version. is using some robust rewaving functions. We can see already here some green area in the progress, and our model looks very good in structure, so there is no breaks, and it looks like a layered structure. So our first stage goal to have a good start approximation. So it should be a layered model, good structured without breaks. I think it should be last iteration till the end of inversion, and we can do next steps because there is no reason to continue inversion because it's already pretty good. So this big value of misfit deal is just a noise. Okay, it's done. Now we have every station. As you see, this station may be not so good, but it's because there is will be break in structure, but mostly all stations has a very good misfit and structure also satisfying. So what we do next, because of course it's a good structure, we can see it different ways. But I suppose we need to do some inversion. Now, just maybe 3 iteration is enough just to make misfit much better, but not lost our structural properties of this section. So I will use reference model as start model, as this model, and we'll try and not go very far from this. Only 3 iteration, and resistivity and thicknesses will be inverted. So now I'll start from current station and go to last station. It's very quick operation because only 3 iteration will be used. So it's just very basic improvements, a little changes in thicknesses, a little changing in resistivities. Of course, you can see it's already not so good structured, but still, it's still good. We can see more layers now than it was after this pseudo 2D inversion, because they can invert for details. And our misfit is much better. And we still can keep this pseudo 2D structure. So this is good. This is good two-stage workflow. But what you need is, of course, pretty dense data set. So here is, I suppose, about 70 meters between stations from 50 to 100. And of course, all depends on your geology. If there is no such a big difference in geology between stations, maybe you don't need so dense step. Okay, we're very close to end of line, and this zone with negative signals, you can see, yes, anyway, it's keeps a problem because signals negative and it's not that good for inversion. The inversion is done. So next step, just choosing, and it's approximately everywhere green color. Of course, here where we have negative signals, it is not, it's red, but we can do nothing with it. So now I just use separated color scale from pseudo section, even from 10 to 15%. And I can see that here in general one, maybe here is 3 layers, I don't know, 1, 2, 3, 4, and from 5 to 7 layers here in this section. On pseudo section, I can see just 1, 2, let's say 3 layers, 3, 4 layers on pseudo section. Yeah. Oh no, it's maybe 5 on this. 1, 2, 3, 4, 5. Okay, and now we can choose how it will looks like, set color scales and everything. I prefer this type of section because it's keep 1D borders, but it's has a good connections to neighbors. So this is all for this video lesson, and thank you very much. It was lesson about layered constraint pseudo 2D inversion. Bye bye.